provides a perfectly fitting socket for the head of the radius to rotate in. Here's the annular ligament with the radial head removed. It's attached to the edges of the radial notch of the ulna. It's shaped like a shallow cup, wider here than here, to fit the radial head, not just around here, but also under here. So the radial head, while it's free to rotate, is otherwise totally trapped. Now let's go back to the intact elbow joint and see how it's held together by its two collateral ligaments. The radial one arises from the lateral epicondyle. It fans out and becomes continuous with the annular ligament. The two parts of this complex ligament hold the humerus and the radial head securely together. What we see here isn't the edge of the ligament, it's the cut edge of the tendon of origin of a muscle, the supinator, which arises from the ligament. We'll see this shortly. Here's the ulnar collateral ligament. It arises from the medial epicondyle and fans out in a triangle. It's attached to the ulna all along the medial side of the trochlear notch. To complete our picture of the elbow joint, here it is with its capsule intact. The capsule is thin and baggy in front and also behind to allow a full range of movement. There's also a very flexible sleeve of joint capsule here between the annular ligament and the neck of the radius. The elbow joint is stable, that means it stays together, for two reasons, partly because of the strength of the ligaments, which we've seen, and partly because of the shape of the bones. The humerus and the ulna interlock closely and deeply. Their surfaces are curved in two planes, from front to back and from side to side. The elbow and the proximal radio-ulnar joint are considered to be all one joint because they're enclosed in one continuous space. By contrast, the two joints that we'll look at next, the distal radio-ulnar joint and the wrist joint, are physically separate, even though they're close together. So we'll look at them separately. To understand the distal radio-ulnar joint, let's look at the distal ends of the radius and the ulna. The head of the ulna has a rounded articular surface. This part articulates with the radius. This part articulates with a key structure that we'll see shortly, the triangular fibrocartilage. The pointed tip of the ulna is called the ulnar styloid. The broad distal end of the radius has two articular surfaces. This large one articulates with the proximal row of carpal bones. This small surface articulates with the ulna. This point is the radial styloid. Here's the distal radio-ulnar joint with its capsule intact and with its capsule removed. Here's the structure that holds it together, the triangular fibrocartilage. It's also known as the articular disc. It's attached to the radius here and to the ulnar styloid here. As the distal end of the radius rides around the head of the ulnar styloid provides the pivot point. Now let's look at the wrist joint. Though we often speak of it as one joint, there are really two joints here, very close together. They're called the radiocarpal joint and the midcarpal joint. To understand them, let's look at the bones. We'll look at them this way up. 8 small carpal bones form the carpus. Distal to the carpus are the metacarpal bones, numbered 1, 2, 3, 4, and 5. The carpal bones are in 2 rows, a proximal and a distal. The bones in each row are attached closely to one another. The 4 bones of the proximal row are the scaphoid, the lunate, the triquetral, and the pisiform, which sits by itself on the triquetral. The scaphoid, the lunate, and part of the triquetral articulate with the distal end of the radius to form the radiocarpal joint. The distal surface of the proximal row forms a deeply concave notch which the bones of the distal row fit into. The bones of the distal row are the trapezium, the trapezoid, the capitate, and the hamate. The capitate and part of the hamate project proximally. The bases of the 5 metacarpals articulate with the distal row of carpal bones. The first, the one for the thumb, articulates by itself with the trapezium. The other 4 articulates in a row here. The distal row of carpal bones articulates with the proximal row here to form the midcarpal joint. The projecting capitate and hamate fit into the notch in the proximal row. When flexion and extension occur at the wrist, the movement happens partly at the radiocarpal joint and partly at the midcarpal joint. When radial deviation and ulnar deviation occur, the action happens mainly at the radiocarpal joint. Here's the wrist joint, or rather joints, with much of the capsule removed, and the 2 collateral ligaments here and here intact. Here's the radiocarpal joint, here's the midcarpal joint. The radial collateral ligament goes from the radial styloid to the scaphoid and its neighbor, the trapezium. The ulnar collateral ligament goes from the ulnar styloid to the triquetral and pisiform bones. Here's the wrist joint with the joint capsule intact. The joint capsule is thick and strong all the way round the joint. On the extensor aspect, the capsule forms the broad dorsal radiocarpal ligament. On the flexor aspect, it forms the palmar radiocarpal ligament. Unlike the elbow, which is held together partly by the interlocking shape of the bones, the wrist joint is held together entirely by the strength of its ligaments. The 2 collateral ligaments hold the bones together in radial abduction and ulnar abduction, and the radiocarpal ligaments hold them together in flexion and extension. The strength of the radiocarpal ligaments also ensures that when the radius rotates, the hand goes with it. Before we move on to look at the muscles, let's review what we've seen of the bones and joints.